computing it, right? Cool. So that should work again. So again, regular expression is about, you need to figure out exactly what you want to match. Do you want to be very concrete, specific, only match a particular case, or are you interested in matching the structure rather, right? In this case, we're matching a sum expression basically, right? Generically now. So so you can obviously extend that to matching subtraction as well, for example. But this is basically the idea. Cool. So yeah, the next example would be, for example, to match a password with alphanumeric characters, length 8 to 24. Any ideas? So if you had. Yep. Anyone? Is it too easy, or is everyone there already? Then I can speed it up a bit. Or I would encourage you to participate. It really makes it a lot easier, because if you're sitting at home later alone and trying to figure out whatever happened here right now, it will make it a lot harder. I think it's a lot easier if everyone has a go at it right now if possible. So we want to have a password that has alphanumeric characters, so letters from A to Z, and has between 8 and 24 characters. How do we test that? Should be a straightforward one-liner, basically. Please.
Double brackets, colon, alpha.
You mean squared brackets, is it?
Yeah.
Yep.
Double square brackets. That's one.
You want to do, yep, cool. Let's do POSIX. Cool, yep. Alpha, I said.
Only the alpha.
But I think then you only get alphabetic ones. You want alphanumeric, right? Isn't it? Or is it only alpha? Let's check the. That's why we have specifications. Hang on. There we go. So it's an ASCII. Let's go. So if you go, yeah.
You went past.
I meant past. Sorry for that. Where was it? That is one. No. What I'm looking for, I'll tell you in a second, is the explicit POSIX ones. Hang on. Yeah, it'd be one way. So that's the para one. There's the POSIX ones. So there you see. So what do we have? Alnum is it here? Alphanumeric characters. So those are the ASCII character classes that are kind of in a mnemonic way expressed. So instead of writing alphanumeric using the numbers and actually letters, so you see here, that would be the intuitive way of doing it. You can just write alnum, yeah, in this particular case. So that's the Go variant of that. So let's try that. Alnum, cool, and then, yep. How do you go from there?
Curly brackets.
Yep.
8 to 24, and then close it in hat and dollar.
Very good. Why do we do that?
Because if you don't do that, you can have any character in front, so you will accept unlimited length.
Yeah, exactly. Yeah. So I did just now. We have a space in front of the actual password. That's probably not going to match. However, if we remove it and run it again, then we have actually matched. So again, here the match is indicated down here. So yeah, that kind of works. Sweet. So let's do. So that should hopefully not work. Always need to check the counter case as well. So yep.
Just want to comment that it does seem like a strange way of implementing shorthand. Would it make more sense to have constant string some namespace somewhere? Instead of having like here you like implement a regex expression which links to another regex expression. It will make more sense to like have like a constant.
So you mean that num or something like that would be expressed as a constant and you concatenate them as part of your expression? Ah, right, okay. Right, I understand what you mean.
It should be noted that this will not accept Norwegian characters.
Well, that's possibly true, yep. And no umlauts either, yep. Yep. It's ASCII only, yeah. I think it's ASCII only, right? Isn't it? Yep. Yep. So we try. But to your point there, yes, you can in principle do that. The only problem is, hang on, it doesn't. It will break now because it's too short anyway. So yep, it breaks, right? So it's only ASCII characters. So bad luck.
But you can put them inside
Yep.
square brackets.
So we can try that.
Oh, there.
You mean
There.
there? See how that goes. There you go. I haven't tried that yet, I must admit. But cool, yep, that works. Cool. So fix for that one, for all the non-conventional Europeans, pretty much for all Europeans that are not British. Anyway, back to MEC. So yes, you could do that, but I'm wondering if the legibility becomes easier. It makes sense from a programming point of view, especially if you kind of finalize your representation. Are you thinking about externalizing the entire expression into a constant, or only a subset of it? What would be the subset you would?
We could do both. What I'm saying is that why make it a regular expression when you can have a regular expression?
Yeah.
Why not make it a string constant instead, which is a regular expression?
Sure, you can. Sure. So you want to have that into a variable? Yeah. Right now it's more like we are hacking around here a bit, but yes, absolutely, we can do that. In fact, I just
think it would be much less headache.
Yep, that is perfectly fine. So cool. Yeah. So it's a very generic approach of actually doing that. Yep. Cool. Sweet. Yep.
What I meant
Okay.
was like instead of having like alnon even exist, you have like a constant which is the regular expression which alnon represents.
Yeah.
Instead of having
So meaning you have but this would mean that you rewrite pretty much the entire regular expression specification in the form of constants and then combine those, right? Is that
I'm just saying like if instead of having like regular expression and making another regular expression, it makes more sense to
Right.
develop a constant instead it actually is. And then you can like subtract the constant, etc.
yeah. I'm just wondering if it becomes more readable or not doing that one, right? But because right now the idea is if you keep it this way, it should be fairly readable to anyone who has remotely any idea about regular expressions. If you start, mixing it with Go-specific elements, it becomes really, really hard to debug it, and you'll see that for bigger regular expressions. I think your competitive.
Wasn't this those specific?
There are well, in a sense that it's a variation of the syntax. For example, the only difference between Go and conventional POSIX would be that you have a double square brackets right now as opposed to a single one, for example. So it's actually fairly aligned. So if you take those dialectical elements into account, it's still kind of readable. But if you put yet another level of complexity on top of it by really, streamlining the representation, which I totally get it. I'm not sure if it make life easier. You could think about this for ready, fully fledged and completed projects. But for this kind of prototypical approach, I think it's a lot easier to at least start this way. Yeah. So it would be the next level of refining. Personally, I generally, if I work with regular expressions, I test them this way first, as simple as possible. So not starting to implement them in your fully fledged code, and you want to build them bottom up, step by step, especially if they're more complex. And we get to that in a second. But I will also point you to some pages that are actually quite helpful. Hang on. For Go, there's a specific regex tester. It's actually not the most efficient one, I just figured out earlier, but it actually does the job. If we just copy our expression in there. So, see how far we get. What did I say? What was it about? And this one. Yeah, it requires internet. Did I forget this? Yes. So, yeah, I'm not sure it does anything right now. Huh. Well, let's take its big brother, see if that works. So again, that's let's see. So what's the character presentation here? Probably need to. I think here we won't get around using a conventional representation. I'll try it with a single. Doesn't seem to meet the POSIX. So let's do it. 0 to 9. So I'm not now. That would be the alternative. I guess you guys gauged that already. So that would match as well. Let's see what we get here. Ah, there you go. Cool. That actually matches. So let's see if we can smuggle in the. Yep, that works as well. Cool. The or doesn't. Cool. But at least so. Yeah, right. That would be an alternative way. Please.
Write A to O as the range.
That's an interesting one. Let's try. Wow, you're actually pushing it there. I haven't tried that at all. So where's my A here? 2. Oh, okay. Frankly, I doubt it, but okay, that works. Would that the OR's? I think you need to list them manually. What? OR's the last one?
Yeah.
And that is the first one.
Yeah.
It's the first, so I got that kind of right? So it was by intuition, not by knowledge here. But no, it doesn't seem to detect that range of special characters. In this case, however, you can just list them, which aren't too many anyway, so you just...
Or is the last one, so you have to have that at the end. Range.
Are you talking about the Norwegian alphabet?
We're trying to figure out the... Yeah, so which one would be the first one? The one I had or the one I didn't have? This one?
That's the last
Or this one?
That's the first one.
First one, cool. 2.
Last one. 4.
This one.
no.
The... Yeah, that's why... Who wants...
The one that looks like an A with stuff on.
Okay, thank you. This one?
Yeah. 4.
Alright, sorry, I'm still learning. It says generic error. It doesn't detect it as a range at all. No. So in this case, the only choice is, and that's the same for umlauts as well, you can only explicitly list them as well. So it's the only way of actually dealing with them. So, but this way they are matched at least. So, but it should be fairly feasible because not too many of them, right? Does that make sense? Yes, no, perhaps? To some extent, yeah. So this is basically the expression here just says what is permissible in that particular string, and it can either be ranges, for example, numeric ranges or character ranges, or any other character you want to match as well, right? So, for example, I don't know, sharp S in German, for example, is another one of those. It's not included. So, cool. And then 8 to 24. If we match on less, it will obviously match. But if we have the termination rule in there, then it's probably quite different. Hang on. If I increase the number to 20. Cool. Okay. Sweet. So that kind of, I suspect, kind of makes sense. All right. Another one that is a bit more involved. Any idea how we could, for example, match all the fruits there in one go? Just write them down because escape from that screen a second. What's the time now? Well, I'll tell you what, let's take a 10-minute break if that works. Right, so this is 1 hour over already. And the ones you want, you can actually figure it out. In the meantime, let's see how far we get. Yeah? Or we'll give you another 5 minutes after that. So we are back here at what would be a reasonable time. Let's make it 1:30. Is that okay? So we have 15 minutes. That includes some, 5 minutes of hacking and figuring out what's going on there, right?
they're actually in the ASCII
Yeah.
table. They're in the wrong order.
Oh.
So you get
Okay, let's try it. Let's try it out.
O is first,
Yeah.
and then
So let's see. Perhaps we figured out. So
Ö is last.
now help me again.
Yeah, this is the first one.
Pronounce it.
O.
Oh. Oh. Okay. Learning. Oh. Yep. Cool. It was O then.
And then Ö.
Ö is the last. So it was this one.
But then you get all the other characters which are not
This one. What's how that pronounced? A.
A.
A. E.
A.
E. O. E.
A.
A.
Almost.
Fall off. Completely off, right?
Yeah. It's
It's not easy.
it doesn't exist in other languages. Sound maybe in Icelandic.
But yeah, I think you're right. So we actually, yep. True, that matches as well. So let's do something that doesn't match. Let's use, do you have any character that doesn't match? Let's use that Ö thing. That's the only one I know. So let's see. No, it's the capital O. Do we have a character we can't match? Yeah, what about Ed? There you go. That should break. Yep, and it breaks. Cool, well done, well done. We'll go into that in a second because I think it's worthwhile for you guys to know.
Yeah. And
good point, actually. Yep, you found some for
yeah.
Ruby?
Rubular
Yep.
is what I use for
Cool.
it's really helpful.
Very nice.
It highlights the
Yes.
the matches. You can have multiple strings and see.
This one does it as well, actually. It's actually quite nice as well for the same purpose. Regexa. Did you find anything Ruby specific there? That's usually my questions I ask because I'm always worried that. There you go, Ruby version. So you want to have it as generic as possible. So and this one is fairly okay. Apart from escaping, it doesn't get the bash escaping right.
Yeah.
But other than that, it's fairly escape. But I probably need to go give it a go as well. What's the name again? Rubular.
Rubular.com. Yeah. It's how I learned. It's
the best
so
way to learn.
important to just
See, get
in
feedback.
live,
Yeah.
by real time.
I do it the same way. Literally, I use those tools, and then once I'm kind of there, copy paste into Go, and then go from there. So I'm building incrementally
Because
on
it's
it.
too slow
Yeah,
to do it
exactly.
at compile time.
Exactly. But also it's intransparent. Here it's very like you said exactly right. So if you have multiple texts, you can have an invalid, valid one at the same time, and you kind of validate them on the fly. So.
Because many times a lot of use cases is that you have a web page and you want to scrape like small tags.
Exactly.
Or something like
Nice.
so
Well
you can
done.
just input it. And
Can you generate this, or did you make that up right now?
no, I just did.
Copy paste and then put it in. Right. Yeah. Sweet. Cool. Nice.
I lost my reference code.
Yes, I got a forward email from Marius for you lost your reference code, so you don't have the code anymore. But you know your repository. Oh.
Yeah, I know the URL, but I'm not sure if I sent in the right one. I think so.
Okay. Would you happen to have time after the lecture?
Yeah.
It probably takes a bit longer. Then we dig in and see what we find. If that's okay for you. Yeah. So that's a good idea. But I know your case. Marius forwarded it to me, so we'll follow up. Just once we wrap up at 2, we just go to my office and do it there. Yeah. It's probably easier. Amazing.
Yeah. What I was trying to say was that with the constant stuff is that when you have it like that, you can have like a static classes somewhere where you just like it could be called like regex. So you press like regex dot, and then you get like a list of
Expression elements, right?
expression elements, yeah, like stuff like what was it called, an alnum or something. And when you have that, it makes coding so much faster. Because writing regular expression is
I know what you mean. You mean context sensitivity, right? So that's what you're looking for, right? But the expression per se, on the other hand, if you think about it, yeah, you could do it, but there's no constant here at least. So that's the package, the regular expression package by Go. Just checking if it had any of those constants. I know what you mean, because we had it for, let's say, the HTTP methods, right? So we had get, post, put, and all that kind of stuff, right? So you would expect the same thing here. I don't think it really exists generally, because the variation is too large to do that meaningfully. Also, it's one downside, just a second. Well, it's one downside, you will always need to reference your, or let's make it a global constant, so that would work.
Yeah, that's what I meant. Yeah.
Otherwise, you would write something like regex p dots and then the constant, right? Would also look weird though. regexp constant plus regexp constant if you concatenate them. I don't know. But I think, but I know where you're coming from. I know you're thinking. I totally get that.
And I'm coming from C# where everything is like a dot away.
Yeah. I know. I think. Well, I think you can try and do that. See how far you get. What you probably want to look more into is DSLs for regular expressions. So DSLs are domain-specific languages that have context specific selection. So instead of just saying regex.alpha_num, regex.alpha, regex, and then the cardinality or whatever else, you actually get a subset of the selection based on the preceding statement. So it's context sensitive. Yeah, truly context sensitive.
Yeah.
So it was like a hierarchical, as if you build a class structure of a regular expression.
I understand what you mean.
And that is much more powerful. So I'm wondering if there's something like that available. That may be an option as a package or plugin.
Yeah.
But right now I'm just teaching you raw stuff. Later I'll give you a bit of a homework for the validator. There's a validator there, and I want you guys to deal with this thing and make up your own mind what you think about it.
I hate it. What? I hate your suggestion. It's complexity on top of complexity.
Yeah,
A new level of layer, which makes it more less understandable.
what you need. Less
need to help with the
Practically.
You hide.
Yeah, you want to have it.
You don't have to understand.
What will happen generally?
You just
tomorrow at particular. So I'll talk more about regular expressions. Happy being just now or just came in?
No, I just came in.
Cool.
I'm waiting for Simon. We were supposed to meet them around 12.
Good luck with that.
Yeah.
That's an interesting one. Do you know regular expressions
Yeah.
to some extent? It's just a matter of hacking around. So what I think, for today and tomorrow we'll just introduce regular expressions more and give a bit of homework and throwing it in Go. Tomorrow I will briefly show how to do it in JavaScript as well. And that will be pretty much it. So giving students an opportunity to explore, and I want them to actually do hands-on. But it's more like a mini tutorial exercise, just along the lines of try to encode the following structure as a regular expression, and try it out with JavaScript or with Go or that kind of stuff. So it's really more helping out with whoever attends in the first place and whoever actually approaches it in the next sense. And probably tomorrow I need to talk about the assignment if it hasn't been talked about already. I will inquire in a second. And then we go from there, but that's not topic for this week at all. I really want regular expressions there because just so people are aware of and can use them in the assignment. That's basically. But the stream is online, the slides will be online, and there's technically no magic associated with this. So because we just run through a few examples and debug our way through. And there's no harm doing the same. I mean, with students, if they want to figure out particular things, well, use the same tools and then debug it away, like using the regex web page or something. So nothing super complicated. But we don't have a we don't have a set out with neat tutorial exercise sheet. That's not the kind of thing we have right now. So but it's basically just getting comfortable with the environment and tools. And did you see Go before?
I've been going through a bit of preparation for it.
Cool. That's good. Well, but it's fine because you can learn on the fly anyway, right? So I mean, let's take off on the like. So, but I think it will benefit you to take away from that whole experience as well, to get a more interesting insight into real problems with Go, like the practical problems where you usually learn the most. Like you guys taking around with JavaScript there during the last game jam time. So that's probably the thing to get away. But I will be a joke for you. It's really nothing. I mean, Go is. You probably figured it out already. It's super easy. I mean,
it's a bit annoying that self-strict on where you can place.
That's right. Right. Yes. And I would like it to do a bit more casting when you, for example, want to print something console. It needs to be all whatever converted into string or whatever. I would like a bit more cleverness there. But it's very rigid, you're right. But it's made for writing robust system software, writing services.
Yeah, it's sort of the big mistakes, the syntax and all that.
Yeah, that's basically it. That sounds good.
But I'll be looking at what you talked about today later.
Yeah. Sure. Just skim through. It's not it's more like discussing through how we build up and those kind of things. And probably have to validate things like probably not getting there, probably credit card or something like that. So it's quite a number of them on email addresses. But that kind of stuff. But I would prefer him to do it, try to do it from by himself, because there's heaps of examples out there, right? So I mean, you can just scrape a very excellent deal, but I want them to think about it and come up with solutions. Because there's the lesson learned should be like 5 different ways to do the same thing in regulation. That's the point. Yeah? So there's no single right answer, and that's what I want to get them to figure out tomorrow. Yeah? Cool.
I might be able to actually help this time around because I was in the evening lecture.
There's nothing.
Well, I got to set myself into Heroku.
So
I didn't know the testing framework we were using, so and a lot of the issues were with the tests failing randomly.
That's fine. Well, but even that's the same. It's kind of getting your head around it because.
Yeah, but now I actually know what you're dealing with, so
cool. No, that's good.
I'll be able to actually contribute.
Yeah. Well, we'll see how it goes. I mean, if you don't feel like it's taking way too much time from your masters, then let us know.
No, it's fine now. We dropped the courses in Trondheim, which
was it the concurrency? You dropped it?
Yeah.
Okay.
The lecturer, she wasn't agreeable. It was not the type of course I like to take. I'm extremely strict, and our assignments were considered exams.
I get your point. Cool. Well, I think I need to yes, go for it. And, cool. I'll let you know if there's any surprises or changes in plan because they're too fast or too slow or whatever. Cool. Thank you very much, Peter. Hello.
I'm trying to match emails.
We're pushing it.
It eats out. I mean, I wanted to stop there, right? I have 2 separate matches, but it eats all the whole thing until the. How do I make it stop at the first? So what do we have?
Yeah, you need to suppress the use of white spaces. Dot implies also white spaces. This one here. You need to be more specific. So you instead of this is fine. This one is the issue. You say something like. So this one, we want just one or more of those, followed by so this one is anything, at least one character, any time. So let's do the same thing in there. So then, hang on. So now we're there. So now, you're having, so we're getting one step further. What it does now, so we came from super general, we're narrowing down to more specific right now. So what it does now is say, hang on, you guys said any character 0 to 9, A to Z, but no dots. So we also need to include the dot into the So exactly, in there, with backslash, otherwise you have some drama. Yep. Cool, so now we have your full match. Cool. So does it only match, is there any constraint on matching the first or second one? So it does the right thing, right?
But it only I don't know if the website is
right. Yes, look at the structure of the email. What do we have there? Exactly, right? So
yes.
Back. Yeah, does it? Okay, that's creepy though. It did it, right? But it could also be any character, so don't do it this way. Be explicit. So there you go. Think about, I mean, it's easy to match everything, and it's easy to match nothing. So, but the magic is somewhere in between. So right now it basically only matched the last one, the initial impression only matched pretty much the last one, because the .no stuff, right? So because it's terminated there, and anything before that. Right, so when we threw out the white space and added the dots, and then it suddenly came up with different approaches.
And then, is there any better solution to, if I want to match .com and .net, is there any better solution to doing this? It's the same as the banana thing, I think. Now I match both com and no. Is there any better solution than listing every single?
No, technically there's no better solution. No. You find it in the registers, they have really a list of all the country endings in there, stuff. No, at this stage it's you deciding how far you give up the rigidity and go for weakness. So you, for example, say, most people say something like 2 to 5 characters.
5? You can have.
Yeah, well, .cloud. .travel 6. I mean, it's getting so open right now. You probably need to rewrite it every month if you want to list them all. So I think you need to be more permissive there. Or it can also be numbers, right? 163.com. So, but I think just testing ranges will probably suffice. Just ranges of numbers and characters and dashes. That I think the only allowed characters in domain names anyway. Underscore is not allowed. Dot is not allowed. Can't be allowed anyway because then it was the well, you can have subdomains, right? So it would be, dot is allowed, but as a subdomain, like something like co.uk and something. But yeah, so I mean, you can have a look at the example. Try to do it yourself. I would encourage it because you learn more. But listing the whole thing was very popular initially. I think most have it dropped because of non-performance reasons. Second one, change, because it's too much constant change there.
Is that also the solution to the banana fruits? You have to list them all.
We go there now. Let's see. Let's see.
Thanks.
You're welcome. Okay. Right, so welcome back, hopefully. Yeah, I think we can start again. Time flew like nothing. Who did the fruits thing? Who figured it out? No one did?
I have to point out that ananas and pineapple are the same.
Yep, I know.
Yeah, I just thought like
I know, I always put it.
all fruits and it sounded like
Yeah.
It's an alias.
Huh?
Alias.
No, I want to have the pineapple in there because it's actually a good, if you have internationals in the crowd, right, especially only English-speaking ones, they will always be surprised that, you know, English is pretty much the only language that doesn't have the term ananas, because if you go to anywhere, you go to Indonesia, you go any European country, including Norway, obviously, it's always ananas, right? So, but pineapple, well, but you know, spice it up, but there is a pattern in there I wanted anyway, so that's why I left it there. But you're right, ananas and pineapple is the same. No harm, we can still match them. So let's match them. Who has any take on it? And then again, what I want to highlight here, when you talk regular expressions, there's generally multiple solutions, right? So it's oftentimes really that it really depends how you attack the problem, but there's generally more than one solution. So if you have a different one than your neighbor, it's most likely that you're both right, because you attack the problem quite differently. Regular expressions are very expressive, so it's really really depends on how you attack the problem. So yep, cool. Anyone? How do we? Or anyone? Does anyone have a solution, or how could we attack the problem? How could we start with the problem? If you have, yep.
well,
what are the patterns?
well, obviously you have to make it so that the word is independent.
Yeah.
For instance, avoid having getting two apples, like pineapple and apple.
Yeah. Okay. Yeah. Okay. So that's one way, but there's also patterns there, opportunities, right? So which pattern should we exploit in any regular expression here? Because if we only want to match those 4 fruits, what are the patterns? Yep.
I think it's nice to divide them into groups.
Yeah.
Because they look quite similar.
Okay.
If we first take it must have an A,
Yep.
capital or
Okay.
small one.
Yeah. There we go. Cool.
That's the first. Yes, and then followed by EPA, the rest of the apple.
Yep.
Then it should get those. And if we want to be explicit, so probably should be also all this should start with pine.
Ah, so okay.
Then it's a problem with this pineapple with the capital A inside. Because it could start with 0, like a question mark.
Yeah, well, there's always an approximate level to which we want to narrow it down. If you want to match them all safely, right? So you just say apple or banana or ananas or pineapple, right? So, but that's the lazy approach. But we have probably some compromises here and there. So that's, I think it's fine, the compromise. What do we need to do though?
Question mark.
Okay. Does that solve the issue?
This one for 0, no.
That's the one for 0, none. Yep, but do we need to think about anything else there? Remember, all those characters, asterisk, question mark, plus, what do they operate on?
Groups. Probably the brackets.
You need brackets, but what? So just to answer my first question, what do they operate on? Anyone? They always operate. Yep.
Groups, but in this case, group is one character.
Exactly, right? So in this case, they would only operate in the preceding character or group, right? So which in this case, since it's not explicit, it's just this very character E. So, so what do we need to do?
After the whole file in brackets.
Yes, parentheses, right? So now we have the fine, question mark, and then the alternative apples. Yeah.
If all that we wrote until now we will put all together in the brackets.
Yep, cool. Note that it also matches that one, right? But that's fine. So again, I mentioned sometimes you take compromises. Cool, yep. So we do that in parentheses, right? Is it?
The other group will be after an alternative.
Yep.
And it will match something that starts with then we have this M-A as this and then
Okay.
probably,
So
or maybe even
how do we go from there? A good subset? Hang on. What? I mean, that's quite straightforward now, I think. What could we do?
small capital A in the beginning.
You said small or capital A, is that right?
Yes.
Good. Okay. Okay.
And then it would not. We will get some false positive, but we can
Sure.
start with B question mark and end with S question mark.
Exactly. Right. Right. So you have a full match, right? So it's one way of doing the full match. Yep. So, but that would be one way of expressing it. Yep. Let me see.
If you want to just get apple and not pineapple, then you probably have to use like a nice character.
If you just wanted to use the apple and not the pineapple, yep, that would be one way. What would be another way? Just keep that expression since we just developed that before we destruct it. In fact, I can just keep it here anyway. So you just want to match the apple without the pineapple, right? Is that correct? Yeah, but in this case that should be relatively straightforward. Because if you do that, then you kind of lose the pineapple already anyway, like, because it doesn't have a capitalized A. So yeah, but basically one way. Is that what you mean, roughly? Cool. So yeah, those are easy ways to construct and deconstruct them. Of course, the easy, lazy one way would be to really write out all the 4 terms, and that's it, right? So again, that's the most specific, most concrete solution, but it's probably not the most flexible one, right? So this one actually exploits patterns that we see. So it's always good to look at for patterns in the structure you're observing. Cool. Everyone okay, somewhat, with what we did here right now?
Excuse me. Are you enforcing capital characters at the start of each word?
You don't, right?
But what do you want?
Then you could have like
Let's try it.
either or capital and
Let's do that, yeah. So how do we arrive there?
I think on the second part, you could make an alternative like starts with A or only A.
This one here?
Yes. So then it's not like it's not coming on B.
Yeah.
Like the two first letters from the banana and ananas.
Yeah.
And the first one from the ananas as the alternative. As BA or A.
Aha, okay. Right. So you're suggesting, so we construct from scratch? It's probably easier, right? No? It's fine.
Yeah.
Okay.
Agreed.
From scratch?
No, I agree with the BA or.
Yep. Cool. So give me a syntax. Yep.
Square bracket.
Yep.
And BA.
Yeah.
With small a. BA.
Including right. This way.
It's
This way.
It's or BA. No, without the capital letter.
Without this caveat. Yeah.
Or
Or
capital A.
But it should be a group.
yep. Right.
Right.
So it needs to be a group of this way. Yep. You're right. Cool. Sweet. Yep. Sweet.
And then it can follow with this steps. This that they share. This
NaNA. Yep. To make an alternative, right? So else it will only match the append to the right-sided expression to the A. So this way we can still match both. Yep. How do we go from here?
And the S with a question mark at the end.
Good.
And it's and probably we can make it start at end marks in this one.
Yeah, but we're still missing something, right? Isn't it? Do we want to match the apples as well? How do we go from here to include the apples as well? Because you kind of pitched the right way, Bill. Because you can go a different route of alternatives right now.
Like building a tree.
Yep, exactly. It's like depends where you start. Exactly. Yep. So.
When,
Encapsulate the entire thing
In.
in group.
Then. Well.
Maybe the entire.
No, you're on the right track, but still, again, we need to have the PPLE somewhere there, right? So what would be the next step?
Yeah, no, yeah.
Well, you could have a group for the apple thing, right? Isn't it? See if that matches. Ananas or apple. Then we have the struggle here again, right? So yeah. Okay, so which one, what do you suggest here? How do we deal with the apple then?
Probably it would be nice to split it as we did in the first one, just to rewrite it maybe a little bit. Because we could do it like this, that it starts with or with the fine or with the EA or with the A. So add like a third alternative.
Here you mean?
Yes.
Cool.
Then it would be only 3 possible ways to start it.
Yep.
Or 4. And then what's followed could be all this NAS with question mark. And as alternative to the second part will be this apple.
So do you mean it like this again, or?
Yeah.
Good.
And like apple and then or maybe just
Then we have the pine issue again. Ah,
you
not.
can just put this PA to the fine.
You mean like this, right?
Yeah.
Cool. Right, that's an alternative way. Yep. Cool. That's more generic. Yep. Cool. Nice one. But the key thing is here, there's various ways of attacking it, right? So it's really about how we do it. Any other thoughts, ideas, perhaps improvements, or no? I'm not looking for a particular answer, frankly. So, because I think we're fairly close here to what would be considered optimal. No? Good. No? Good.
One problem is you can have battle.
Yep, you can. Yes.
If you can live with that. It's okay.
Yes. Again, yeah. So again, the only way of really making it hard, I think, is to write out the 4 terms, literally. Right. So if we do that one, can try that one. It would be fairly unsurprising, I believe. Would be literally like that. Or what is the next one? Apple closing one. Or so that would be the obvious ultimate solution, but banana. Cool. Yeah. So that would be the only really safe match if you wanted to, but that it doesn't make it.
This also would make it.
Yeah, you could do that. Yeah. We could have an awkwardly inverted banana with a capital A, right, in the second position. Should we try it? Just have it out, right?
Yeah.
Yet another one. So it's cool that we have so much. Let's note all of those down. So I'll try that one here. B A and ananas. Cool. Yep. Linear. So I probably missed some brackets here. Hang on. What did I get wrong? Apple. The A after the B, A. Ah, right, you're right. So that would be this one, isn't it? That's what you want, right? A, ananas, cool, P, capital E, A. Why doesn't it pick the banana? Alright, it doesn't catch the banana. Why is that? Yeah, right. So you just need to have that one there. Yeah, and then you catch all of them. So yet another option, basically, of catching it. Yeah. Sweet. What's the there? Again, the only thing that you could have is things like that, right? Isn't it? Banana. Oh, it's fairly. No, that's very cool. Yeah, good. Cool. Yeah, that seems to be like a. Does anyone spot anything there? Probably is a good. Yeah.
Lowercase apple.
Lowercase apple is not matched, which is good, right? So lowercase banana is obviously not matched either. So it's matched. Yes, lowercase banana is matched. True, and lowercase pineapple is matched as well. Yeah. So it's always compromises here and there. I think, but it's fairly close to a good solution. Any further ideas, refinements? No. Yep.
Why not just make it case insensitive?
Sorry?
Why not just make it case insensitive?
Yeah, we could make this whole thing case insensitive. Yeah, okay. But that would basically change the requirements of the entire problem, right? So by making it case insensitive, we would match any sort of fruit, any capitalization. Now we have few outliers, but not all of them, right? So, but yes, that would be one way. If you just get rid of cases, you're sweet anyway. Yep. Cool.
If capital letter is the requirement,
then
you just remove the square brackets. Wasn't it?
True.
Was it a requirement?
I wasn't explicit about it, I believe. You're right. So let's this way. True. And that's this way we get rid of all that drama. And now we could. I think cool. So now it's 100%, right? Any other possible matches we haven't thought about? Well, this one would be an exception. Yeah. So it's the only one that could be done. Plural of bananas, but that's it. Cool. Well done. I'll return the laptop in case you want. Cool. 4 possible matches. Sweet. So, yep. Cool. So that's what possible answers we have. It. Just a few notes before we stopping here. Something about the compilation process of regular expressions. So you notice that they have a lot of power, but what's their key downside is in fact performance. They're kind of really expensive compared to string comparison anyway. So if you can, for example, if you want to ensure that, for example, you have an input and that's just lowercase, or an input that should be uppercase, or any other sort of requirements, or you want to trim them. You mentioned there was some feedback from regarding the SQL statements that you basically remove white space or termination characters at the end or beginning of a string. Then there's other more powerful mechanisms to do that, right? But if you want to have identify structural patterns like we did today, then you kind of need to fall back to regular expressions, but use them cautiously. Performance is an issue with those ones. But how do they work in principle? Well, first of all, the regular expression library takes the expression you want, compiles it into its representation. So it's basically a tree representation of permissible syntax, and then matches all possible input syntax against it. I just want to show you that the purpose is kind of wide-ranging. Instead of just focusing on matching one particular statement, you can do counts of matchings as well. That is quite possible. I'll just see if I can quickly operationalize that in Go. I guess we're running out of time here, frankly. So so I'll probably do it tomorrow. Explore it a bit more, the performance considerations. But the applications of regular expressions are really wide-ranging. So it's validation, input validation for your web application. And I mean, you guys will hear web technologies, I think, next semester. I'm not sure if it's covered there, but it's definitely something you see there again, or hopefully see there again. And if not, then think about introducing it. And again, it will be pain again, because this time you will need to look at the PHP or whatever technology you use, implementation of regular expression. But you have a baseline understanding already. So that's the tedious part about it. If you have worked and taught like 5 different languages, you'll get so confused yourself, because every language does it slightly different as well. So bear that in mind. But we continue tomorrow as well. I want to do a brief Go implementation there, and perhaps have a go at some other options as well. So it's also popular in Unix search. So if you want to do file search or file content search in Unix machines, you can use regular expression out of the box. Again, it's part of the POSIX standard. And obviously the information retrieval and text extraction that we just saw. In fact, the web page regexa was a good example, because it actually highlights all the possible occurrences of a particular match. So that would be a classical use for information retrieval. Cool. So yeah, just bear in mind, again, performance is really an issue. You will see that if you do it repeatedly, it really can wear your system down to some extent, and the massive amount of dialects you need to deal with. POSIX is kind of the lowest common denominator, but most dialects have some additional implementations that are involved. So it's very important to be aware which system you're working with and its syntax. So the one for Golang or Go is under the regular expressions library 2 in the wiki. So it's just the one we scrolled up and down before. So those are all the supported expressions. Note that there's quite a bit of them that is actually not yet supported. So I think that is a considerable work in progress. So if you, I don't know, come back a few months later or something, there you most likely see quite different picture. They have locales implemented as well, but here all that kind of stuff is not currently supported. That's most Vim specific extensions, but also some of the base expressions are not really fully supported yet. So there's a lot of work in progress in that area. So cool. Yeah, if you want to have a look at how Go actually works in the library, I believe we go over that tomorrow again a bit more. The package, the regex package, is obviously fully documented, and you can check out the different methods that are at our avail. We look into those a bit more in detail tomorrow and apply some of them, but that's basically how it worked. I showed you a brief idea of how to go about it if you wanted to use it. So you can just call regex and match strings, but there are other ways of doing that as well. Cool. Go obviously has inbuilt tools as well as the Go validator. We have a look at this tomorrow as well, or you will probably have a look at this tomorrow as well, to bear in mind. Other things that I recommend. So I generally use regexa for debugging it, but there's the Go specific one. Note that it's way slower, the second one, but it's Go specific. So it's probably more useful if you are working with Go apps. And I put a list into here with respect to all the different tutorials that I kind of think they are helpful. If you want to get an introduction into regular expressions just by doing an interactive tutorial, the first one is quite straightforward and runs you through all the basic elements that we talked about briefly today, like cardinalities, character classes, and all those kind of things. The second one is a bit more like an overview thing, and from there on it gives a bit more involved. Here's tutorials with respect to Golang specific some example use of the Golang API with regular expressions. I'll run through some of those examples tomorrow, and for JavaScript similarly, but that's not something that's relevant today because we haven't gotten to that stage. Cool. Any questions? Yep.
Is there any way to say that you have an array of like words or something, and then match those, like if we say that you want an adjective as the first value and then a verb as a second, is there any way to do that?
Yeah, I think that is beyond what you would do with regular expressions generally, because you would need to have a massive library that kind of backs all the vocabulary, right?
Yeah. If you have a subset of those,
yeah.
Like if you are going to make a compiler for Go, for instance, or for C++, and then you have keywords as one array, for instance.
Right.
Is that possible?
It is in principle possible, but I don't think it's sufficient at all in regular expressions, because you're building a compiler on top of a compiler.
I think then you would use some sort of natural language processing library.
Yes,
is built on top.
That is something. And again, I mentioned that before. I probably look at domain-specific languages that do precisely that. The idea is there. They provide you context-sensitive selection of possible, further terms and so on, right? So they would be domain-specific and only basically give you a subset of selection depending on what comes first. However, in the expression case, we're kind of building the whole string in the first place and then matching it to a given input string. I think you could do that, but I'm just saying that it may not be the optimal application for this kind of stuff. It's really more like finding multiple occurrences in a given text space, that is somewhat reasonably complex in terms of structure, but if you go to sentence level at that stage, there's too much power of grammatical aspects to be considered to make it this way. Plus it's not efficient. So for information retrieval in this case, you probably would use more like an index. So you would index all 4 occurrences of those possible terms and then quickly list them, because regular expressions is very slow. I'll probably show it tomorrow. Well, I need internet to see how it goes, but I would show it tomorrow and show you how slow it can actually get. But it's a very good question. Thank you. Let me see.
When you say the Unix search, do you mean like
Bash?
Yeah, you can write up the after the terminal.
Yeah. Yeah.
I was wondering about when is the deadline for the resolution?
Hang on.